Hello, everyone. Let's talk about C13 NMR spectroscopy. So, unlike H-NMR spectroscopy, C13 will have no splitting. So, if you hated having to calculate splitting and try to interpret that, today's your lucky day. On top of that, too, shifts will mainly be determined by substitution. The more substituted you are, the more de-shielded you are. Yeah? And so, let's look at this structure right here. And remember, just to clarify, we're doing C13 NMR spectra, which means that if you don't have a carbon, you can't do any spectroscopy work there. So just had to repeat that just to make sure. So the easiest way you can kind of be able to pick apart the structure and assign it to these different peaks, right, is to look at what is the most substituted. The most substituted will be these carbons right here. Sorry, whoops, my bad, wrong one. These carbons right here. Because they're fully substituted, they don't have any H's on them, and hopefully you're at a point now where you can kind of be able to tell that. If not, then I suggest you kind of review how to draw skeleton structures. So from there, right, I would probably assign these two to the most downshielded ones over here. Yeah. It can be difficult sometimes to tell between these two peaks, but as long as you're able to ballpark it, that's fine too. Now, from there, we can go on to the next set of carbons that are the most substituted. And that's going to be the ones that are on the ring right here. Yep. And I'm going to assign those to 1, 2, 3, 4. There's 1, 2, 3, 4. The last one is going to be this little carbon right here. And it's going to be assigned to here. Yeah. So basically, as you can see, it's very, very easy for you to assign C13 NMR spectroscopy. C13 NMR, I can't talk today. C13 NMR peaks just by substitution on its own. And on top of that, too, there is a small little vocab thing that you should know, right? But the most substituted C13 peaks, right, tend to be the shortest, as you can see here, right? Hopefully, I've illustrated that here. I don't know if I made it so clear with this one, right? But you can kind of get the point, right? These two are very, very small, and kind of the reason the phenomenon that governs this, right, is called the nuclear Overhauser effect. Sorry, let me just change color so it doesn't confuse people. But yeah. The nuclear Overhauser effect. Just basically explains that the more substituted you are, the more substituted carbon is. Carbon equals the shorter the peak is. Yep. And so you can basically do this. Probably going to be a question dedicated to it. That's just probably going to ask you like, why are the most substituted peaks, right, the shortest, right? And so just make sure to understand kind of how this works. But other than that, that's basically all the brain power you need to devote to C13 NMR from my experience. And so hopefully you guys have been studying and you guys have good hunting on your next exam. See ya.